Hi, I hope you're doing well. I hope the coronavirus is not disrupting your life too much. For this video lecture, we're going to talk about sentiment analysis. So sentiment analysis is where we take the words and from some documents, and then we attribute like positive or negative or neutral attributes to those words, and then we analyze but we convert the words basically to this the sentiment, and then we look at what the sentiment is overall for the document. All right, so to be consistent with what we've been doing so far, we're going to be looking at tweets. So for this example, I'm going to be looking at Vice President Biden's tweets and President Trump's tweets, and we want to take a look and see how they're different. Now, the data set that I've got in here is posted in files within Canvas, and I've left the code in Canvas also, and we've got this document posted, so if you want to reproduce this, you can. Now, there are some more ways to do sentiment analysis within R that are pretty standard. I found that the ones that I'm going to go over with this video are the simplest and fastest ways to go through that involve the least amount of data prep. And since there was less data prep, I felt like that was a better way to approach it. And if you are more interested, if you want to start getting into the more technical sides of sentiment analysis, you can definitely take a look at the packages I refer to at the very end of the video and dig in a little bit deeper and take a look. I think this is very interesting. I really enjoy this type of analysis. All right, so the first thing I got to do, of course, is to go ahead and load the data. So I need to prepare the tweets. So like what I've done previously, I take where my data is stored. This is where it's stored on my computer. And then I use the read CSV function to read it because it's stored as a CSV. And then I use the lapply function to grab everything. Now, something about the read.csv function is that by default, it's going to interpret categorical data as factors. So then the tweets will be treated as factors, and I'd have 6,400 levels to the tweets column. Wouldn't make any sense at all. So what I'm telling read.csv to do here is to interpret all categorical data as being a character. All right, now once I do that, so in this format, I've got a list of 2 items. And the first item in the list is a data frame. The second item in the list is a data frame. I need to put them together to be one big data frame. And so I use the dplyr package bind rows. And just to make it a little bit easier to work with, I'm limiting the data to just the screen name and the text. All right, so if you take a look at the original data sets, there's a whole bunch of other columns in there. For this project, I don't need them. It's not informative. This is what the packet, what my former code will pull up for us. All right, so now I need to go ahead and start doing some data prep. So I'm going to prepare the strings. All right, so in the previous video, I went through, I removed emails, I removed hashes, or hashtags, I removed websites, and I was more particular about it. For the purpose of this video, I want to get into sentiment analysis as quick as possible, so I'm kind of doing down dirty. I could definitely do better. I just want us to see what's going on. So you'll notice I use the gsub command, so I'm going to go through, I'm going to make a substitution. Every time I see a term that corresponds to this / capital W, and that is a capital W, I'm going to replace whatever I see there with a space. All right, so what this is doing, this is going through and this is getting everything that's not almost everything that is not a letter or a number, almost everything, not quite everything, and replacing it with a space. All right, so this is really good because it gets rid of a lot of punctuations and special characters for me. Doesn't get rid of all of them, but this is a kind of a quick and dirty way to start getting into my data pretty fast. And I convert everything to lowercase. Now, when I took a look at what was left, I noticed I had some underscores, and so I went ahead and replaced the underscores with the space. And all right, so here, this is not what it looked like on my work computer. I think this is Word interpreting things different. These were international characters versions of A instead of Chinese or kanji, whatever those are. Once again, this was like a superscript 3 previously, and I replaced it with the number 3. Probably should have just gotten rid of it, because on my next step I get rid of all digits. Now when I do this, you'll notice that every single time I've been replacing whatever I pull out, I replace it with a space. So I'm going to have a bunch of extra white space in there. The extra white space is going to slow down the process that the computer is going to, for upcoming steps, it's going to actually pass through all those spaces and read them. Well, if I have junk in there, it's going to slow down the process, and I don't want that to do it. So I go ahead and I just get rid of all of the excessive spaces. So if I have 2 or more spaces, they get replaced with a single space. So this /S+, I'm telling it to find multiple adjacent spaces, replace it with just 1. All right, now I need to go through and I need to remove my stop words. So I go ahead and I remove the English stop words, the SMART, and the top 200 words. And when I looked at this earlier, it worked out. In the last video I put out, for some reason when I went into RStudio, it didn't work when I did the R Markdown file. I think it worked this time. Hopefully it worked. If any word that is a stop word probably is not going to have a sentiment connected to it. So even if I did not get all my stop words out, it should still run correctly, but there's just excess stuff floating around, which will slow down the process. And after I did this, I had a bunch of extra white spaces again, and so I got rid of them. Also, I had leading and trailing white spaces. A trailing white space is where I have a space, then my first word. Trailing white space is when I have my last word, then a space. And so the trim white space function got rid of that for me. And that's just to clean it up. Even if I would have left it, it wouldn't have slowed down the process much. But, it's good to be consistent. All right, so I was looking through several different ways to go through and run sentiment analysis within R, and I found that this package here is probably the fastest one, easiest one to get into. So that's the one we're going to talk about now. There are other ways. I don't know how you pronounce that, so I'm not even going to try. But what I'm going to do, I'm going to create a sentiment matrix, and I'm using this package. I'm using the get nrc sentiment, and I'm going to apply it to my my tweets. All right, so what that does, that creates a count matrix. So each document, each tweet corresponds to a row, and each column corresponds to a sentiment. Then you can see that we have anger, anticipation, disgust, fear, joy, sadness, surprise, trust, negative. Okay, so if I look through here, the very first tweet that we have, it has one trust word and no other words, no other sentiment words at all. If I look at, let's say, the third tweet, 3 of them involve anger, 1 involves anticipation, 1 is disgust, 3 is fear, 1 is joy, 4 is sadness, and 4 are negative. All right, I mean, there's a lot of sentiment going on in this third one, while there's very little in this first one. Kind of interesting. All right, so if you remember previously, I put my 2 data frames together into one big data frame, one with Vice President Biden on top and President Trump on the bottom. And so now what I want to do, I want to split them apart again, because I want to look at just the authors. So what I'm doing here, this command, I'm telling it to take my sentiment count matrix. Here's the head of the sentiment count matrix. What I'm going to do, I'm going to split them by Biden, Trump, and I'm going to put the 2 sub data frames into a list. First one's going to be Biden, second one's going to be Trump. Now, what I want to do, I want to just look at Biden overall. I want to look at Trump overall. So what I'm going to do, I'm going to use the column sums function, and I want to add up all the times that President Biden used a word that is associated with anger or anticipation, disgust, fear, joy. So for each one of these words, I'm going to have a President Biden sum, and for each of these words, I'm going to have a Vice President Trump, or to be a President Trump sum also. And that's what the column sums are going to do. Remember, the columns go up and down, so I'm adding along the columns after I split it. Okay, so now something that is going to be kind of interesting is, well, what's the difference? Realize that we've got about 3,200 tweets for each of these political candidates. I mean, that's a lot. And really what I'm interested in is not really so much of how many times they use an angry word or how many times they use a surprise word. I'm interested in the difference between them. You know, we're talking about political opponents. What's the difference between them? We don't want what's similar, we want what's different when we go out and vote for them. All right, so here's what I'm going to do. You'll notice I took list sentiments, and then I applied the lapply function, and I've got the list sentiment list. What it is, the first item in it is a vector for Vice President Biden. The second entry on there is another vector for President Trump, and these are the column sums from their data frames from the sentiment matrix. All right, so now what I'm going to do is I want to look at the difference. So I'm going to do subtraction. If I see, I'm going to take the first entry minus the second. So here, this is Biden, and subtract Trump. All right, so if we see a positive number, we know that Biden has more counts on those types of words. If we see a negative number, we know that President Trump has a larger count on those words. And then I go through and I sort it. So that way we have the most negative ones first and then the greatest ones last. All right, so what that will do, the words that are used more frequently by Trump, or the sentiments that are more frequent from Trump, will be first, and the words that are more frequent with Biden will be last. And I'm using the sort function for that. And then I'm using names to grab just the terms. So here, what this is, it's these terms that I've got here: anger, anticipation, disgust, fear, joy, sadness, surprise, trust, negative, and positive. But they're in order where the first ones are used more by Trump, the last ones are used more by Biden. Now, I have approximately 3,200 tweets for each candidate. All right, so I'm not going to really worry about the percentage for each of them. If I had a largely different number of tweets from each candidate, I would be doing a little bit more work with this to make sure that I'm computing off of the proportion of time sentiment words are used. But since they're about the same, I'm not going to worry about it. All right, so here, let me make this a little bit easier to read. Okay, what I'm doing here is I'm creating a data frame. So first and foremost, the first column is going to be the screen name. So this will either be Biden or Trump. Then it's going to be the sentiment word. So here, it's going to be the sentiment words that we have from here, anger through positive. Next will be the count. So the first column is going to be the candidate. Second will be the word. Next will be the count, the number of times that candidate used that type of sentiment. Now, strings as factors is just put in here to make sure that I treat everything as being a character string and not a factor. You know, anytime you use base R functions, you usually have to worry about factors being, or categorical data becoming factors when you don't want them to. All right, so now And you notice I did this for each one. I did one for Biden and one for Trump. So this is going to be much smaller data sets. And I put them together so that I've got Biden and Trump together in one data set. Now, on this step, what I'm doing is I'm taking the sentiment words by default. If I start like doing visualizations in R is going to take things and put them in alphabetical order if I don't tell it otherwise. All right, so to tell it otherwise, what I have to do, I have to put it in a factor. So think about Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Those, if I have that, like those types of characters in my data set, R will interpret those to be needed to be in alphabetical order by default if I don't go through and change things around. So, of course, you get a very wonky order if you alphabetize the days of the week. It wouldn't make any sense to your reader. So what I have to do, I have to take the data, I have to tell it specifically what order to put it in. Well, this order is exactly what we did up here. I overshot it. Up here, yeah, I did it over here. So this, remember, I went through, I made sure that the President Trump tweets are first, and the President Trump sentiment terms are first, and the Biden terms are last. Now I want to go ahead and plot what I've got so far. All right, so when I plot it, what I'm going to do, I'm going to use ggplot2. I haven't really talked about ggplot2, but it is absolutely sweet, powerful, wonderful. You definitely want to get to know ggplot2 if you're going to be working with R routinely. It's how I've really made a name for myself in my organization, in making good, solid visualizations. Okay, so ggplot2, GG stands for Grammar of Graphics. What it does, it takes the concept of making visualizations, and it establishes like a formal grammar system that has a functional mapping system from mathematical objects to visualizations. So when I say functional, I mean like a function as in like college algebra. It's actually mathematically equivalent to the idea of a function from your pre-calculus or calculus or intermediate algebra classes. Okay, so what this function does, this function says, this is my data set that I'm going to be working with. The grammar of graphics goes with layers. Whatever I put in first is what's interpreted first, and that will generally be like lower level in the visualization. Whatever comes later is going to be higher up. And so when I stack things on top of each other, whatever is last is the thing that's going to be on top of everything else if I have overlapping aspects in my data set or in my visualization. So this is called the aesthetics layer. All right, so here what I'm going to do, I'm going to say that the X coordinate corresponds to the screen name. The Y coordinate corresponds to the count. Fill is the screen name, so this is the color. So I'm going to fill in some bar plots. The color is going to be screen name, and the label is going to be the count. All right, whenever you do a visualization, you want to put labels on your visualization as much as possible. This part here is how I'm going to do that. I'm going to put the number that is for each candidate actually on the plot. The bar plot will also have that information, but people will interpret it correctly more frequently if you actually put the number explicitly on there. Now here, this is the geom column layer. So, and then I've got geom text. This is basically saying, hey, put the numbers, the counts on my bar plots. And I have to do a vertical adjustment just to make things line up well, make sure the numbers aren't on top of the bar plots. I need to give it a title, bar plots of Twitter sentiment analysis. And the faucet grid, what this does, this is going to break up the individual bars so I'm going to have all the different sentiments, and I'm going to have two different candidates. So I've got a whole bunch of bars I want to create. So we look at this, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, I've got 10 different types of sentiment words. What this does, this says, hey, for each different sentiment word, make a bar plot. You're going to have Biden and Trump along the x-axis, and the count of how many times they use those types of sentiment words is going to determine how high the bar plot is. And there's going to be 10 subplots here. Now, when I'm doing scale, fill, manual, what this is saying is when I fill the bars with color, I want it to be blue and red. Blue for the Democrat, red for the Republican. The theme black, white, if you look at the default theme in ggplot, a lot of people don't like it. I don't know why, but whatever. I find that people prefer the black and white theme, so I just go with it. And then here, legend position top, I'm moving Biden and Trump to the top of the plot to make a little bit more space on the right-hand side. And I'm going to rotate the x-axis label 45 degrees. This is a good way to kind of make it easier for your audience to read, but not make things too crowded. Putting it at a 45-degree angle is a good technique for that. And horizontal adjustment is just kind of moving things around to get things in the right position. All right, let's take a look. All right, so unfortunately, so the sentiment terms kind of got cut off, but let's see what we got. We've got a lot of this is just because I'm passing it on to Word. If I plot this in, if I plot this on my computer, I can see it easily. If I go ahead and save the plot with GG Save, I can control the size of the plot so that the clipping will not be an issue. Here it is, not really a whole lot I can do about it. So here we have negative, disgust, sadness, anger, fear, surprise, joy, trust, anticipation, positive. All right, so the two most frequent, comparatively, President Trump uses negative and disgust sentiment a lot more than Biden does. If I look over here, Biden uses anticipation and positive sentiment a lot more than President Trump. Kind of interesting. Now let's look through. Also, Biden uses trust and joy more. Now these are close enough that I'm going to go ahead and just say that these are about equal. You know, like sadness, these are really tight, really tight. You know, Biden uses surprise a little bit more, but not a lot. So, you know, something to look at. Also, you'll notice that the numbers are getting clipped off. If I'm displaying this on my computer or I'm making a PNG file with GG Save, I can, you know, definitely resolve that issue. But, you know, here when I'm passing it into our Markdown, it's kind of hard to control it. And you'll notice that it's easier to read these terms. If I had if I had Joe Biden and real Donald Trump horizontal, they would be on top of each other. That would be too crowded. My reader couldn't read it. Also, I've learned that if I would have it vertically instead, it kind of it forces the rest of the plot to kind of get tight vertically, and it's harder for people to read. So the 45-degree angle is a good compromise. All right, now I want to take a look at using the QDAP package for sentiment analysis. So, you know, this part here, I'm just loading the package, and you can see that there's a lot of things coming out. The QDAP package has a lot of features to it. It has a lot of capability. It takes a little bit more work to do stuff. You have more options, more tools to work with, but you have to make more choices also. With the previous package, you saw that I just kind of dropped it in, ran with it, and I got good results pretty quick and easy. All right, for sentiment analysis with QDAP, the heavy lifter is the Polarity function. And you'll notice here that I'm using the double colon notation to say that, hey, use QDAP. Here is my text variable, and here's my grouping variable. All right, so what I'm doing, I'm saying here are the texts that I want to have analyzed, all of our tweets. Now the screen name is, corresponds to the candidate. And so here's my output. So we've got the screen name here, the total number of sentences. So it's about 3,200 for each candidate. Here's the total number of words. So we can see that President Biden has more words. Now this is after I went through and I removed a lot of terms. So remember I removed all of the non-printable characters. I removed all the stop words. So after making that adjustment, we can see that President Biden has a larger number of words used. His average polarity is 0.1 and standard deviation is 0.4. So statistically not significantly different from 0. President Trump, we can see slightly negative 0.5, and then standard deviation on the polarity is 0.5. So not statistically different from 0. And let's go ahead and take a look at the summary statistics for the polarity of both candidates together. We can see that negative 1.8 is the most negative tweet out there, while the maximum is 1.96. So everything's between -2 and 2. So now let's go ahead and plot. All right, so here, what this is doing, this has all of the tweets as they are in the original data set, and when I see red, that's going to be a positive sentiment. When I see negative, that's going to be a blue. So we kind of visually look through. When I see the white, I know that is a neutral sentiment. And how I had the data set arranged was that Vice President Biden was on top, President Trump was on the bottom rows of the data set, and so that's why these bars of color are not overlapping at all. And now here we can take a look at a scatter plot. Actually, this is a jitter plot to take a look at the difference. So we can see that there is kind of a difference. Now you'll notice that there's a lot of zeros floating around. All right, so now let's go ahead and let's go through and let's actually start plotting it. So with ggplot. So up here, this plot command is kind of like the default one. This comes out of the package. It's really nice. It's really informative. I get some information out of it. But if I want to dig deeper, ggplot is a good way to go. But I'm going to need to make sure that I have a data frame set up correctly. So what I'm going to do, I'm going to make a data frame. I'm going to take the screen name from my tweets data set. I'm going to go ahead and pull off the polarity. So polarity, all, polarity. Notice I've got the dollar signs in between. And I do not want strings to be factors, because in that case, the screen names would, if this was true, screen names would be a factor instead of a character string. And for this project, it doesn't matter, but I want to keep it that way, just be consistent. All right, so now on this next step, on the visualization, I decided to get rid of everything that's 0. So everything that has 0 polarity, I got rid of it, because you remember we're looking for what's different between the candidates. Also, if you recall, if I look back at the summary up here, I had 4 missing values. So what I did on this part here, I said do not include anything that has a missing value for the polarity. And so I'm using the grammar of graphics once again. Here's the static layer. X is the polarity. Fill is the screen name. And then I'm going to make histograms. And I'm going to make 2 histograms, one for Vice President Biden, one for President Trump. Here is the title, and this is my command to tell it to use blue and red. I'm using the black and white theme, and then I put the legend up top. Now this warning message here is just saying, hey, I'm using the default binning for the histogram. If you want something better, like just pick something better. All right, let's take a look. All right, so something that should jump out at us is that, so first of all, remember I removed all of the 0 sentiment tweets first. So here, they're all gone, they're all gone. So when we have positive or negative sentiment, either way, they're really, most of the time, they're not that extreme in sentiment. We can see that President Biden does have, at least for the mode of the distribution, has more frequent positive, and President Trump has more frequent negative sentiment. Shape-wise, they're not that far from each other, but we see this, except for this big spike here, which is, you know, slightly positive sentiment. All right, so there are other ways to get into sentiment analysis within R. There's the tidy text package. I was looking through it, and I felt like for what you get, it's a lot of work on the data prep phase. So I don't know if we're going to go over it. I might do that for the next video. I'm kicking around different ideas at this point. But I kind of want to show you like different ways to approach sentiment analysis. So here, so remember previously in our so far we've been looking at different types of sentiment words when we had like the anger and surprise and joy and whatnot. And then we got into numeric values. I can go through with the tidy text and text data packages. We can go through and like pick different lexicons for sentiment. Some of them, you know, give like different scores of like ±1, ±2, ±3, or 0, and so on. So like the AFIN does that. The NRC goes through and attributes a particular sentiment word for each type of word. So we're not getting a numerical value. What we're effectively doing, we're replacing the abacus with trust, abandon with fear, abandon with negative, abandon with sadness, abandon with anger, and so on. And then we count up the number of times we have all these words coming up. Now the Bing package, what it does, it just says positive or negative. It might say 0 also, I can't recall. One of the get sentiments packages has neutral also. And so here it's basically a binary choice, positive or negative, and we don't get a magnitude of it, and we're not being specific. So one thing that's nice about this, if you need to make it simpler and easier to interpret, just having 2 different choices is a good way to go. But we do lose information on the magnitude, and we also lose the fact of that there's, sentiment is more deeper than, plus or minus 1. And that is all I've got. I hope you're doing well. Please let me know if you have any questions. Take care.